In this lesson, we're going to be converting between degrees and radians. We're also going to be revisiting the topics of coterminal angles, complementary, and supplementary angles. All right, to convert degrees to radians, we're going to multiply the degrees by pi radians over 180 degrees. If we want to go from radians to degrees, we're going to multiply the radians by 180 degrees over pi radians. So just notice that the relationship between these two expressions are that they're reciprocals. All right, we're told to rewrite each angle in radian measure as a multiple of pi. Do not use a calculator. All right, 315 degrees. So what is that angle measure in terms of pi in radians? Well, we're going to multiply by pi radians over 180 degrees. I'm just going to leave off the word radians and multiply by pi over 180 degrees. So I might as well go ahead and make 315 degrees over 1. Remember, it says do not use a calculator. So for me, I would look for common factors of both 315 degrees and 180 degrees. I'd look for common factors. I think 5 goes into both those numbers if I didn't have a calculator. Otherwise, if you just multiply the tops and the bottoms together, you get 315 degrees over pi. You get 315 degrees pi over 180 degrees. Now, the degree symbols are going to cancel out. So the degrees go away, and so we're going to be into a radian. All right, so at this point, if I look for common factors of 315 and 180, I know 5 goes into both of them. But I would say at this point, let's just use our calculator. I know it says do not, but that's going to take a while. So let's build the fraction bar. I'm going to put 315. I'm not going to put the degree symbol. I'll put pi. I'll put 180, and I'm hoping, it changed it to a decimal. Yeah, so in that case, probably because the pi is there. Let's go ahead and revisit that and do this. Let's do 315 divided by 180. How about if I did it right? 315 over 180, and hopefully it'll keep our answer as a fraction. Yeah, so then we end up with 7 pi over 4. And of course, we could put the word radian there if we wanted to, because I'd have the word radian here. But with or without rad, we know that 7 pi over 4 is a radian measure. Okay, we have the ability to check that. If we go back to one of our unit circles that we worked with in a previous lesson, and one of our unit circles, and specifically our pi over 4 circle, remember 315 degrees was way over here, almost one complete rotation, and its angle measure in radians was 7 pi over 4. So we have a way to check our work with some of these. Well, let's go ahead and look at 120 degrees. 120 degrees must be on the pi over 6 circle. 120 degrees is a multiple of 30. We should end up with 2 pi over 3 as a radian measure in terms of pi. But again, the conversion is to multiply by pi over 180 degrees. You can put 120 degrees over 1, so at least show what you're multiplying by. So I know the degrees will cancel. I'll go ahead and do that right now, and I'll get 120 over 180. Without a calculator, I would know to divide out of 10, which takes away those zeros. And then what goes into both of these? 6. So 6 goes into 12 twice, 6 goes into 18 3 times. So I end up with a radian measure of 2 pi over 3, which is what we saw from our circle. So in all these problems right here, we're going to be multiplying by the fraction pi over 180 degrees. If you want, you can go to your calculator. Notice that the degrees will divide out. The zeros will divide out because they're tens. I'm left with negative 33 over 18. I know 3 goes in to both those numbers, so I end up with negative 11 with the pi over 3 goes into 18 6 times. Well, that's certainly something I can check. Negative 330 degrees, that would be on this circle, and I would go negative just 1 pi over 6 section or 30 degree section shy of a complete rotation, and so that would be, negative 330. So I'm going negative 330, so that would be negative 11 pi over 6, which is coterminal with pi over 6. So pi over 6 is the positive measure, but negative 11 pi over 6 sections would be coterminal with pi over 6. Okay, 144 degrees is not one of the degree measures on the pi over 6 or pi over 4 circle, so I know I can't check this one. So for that one, instead of just kind of dividing this out by hand, which I know both these numbers are even, so 2 would divide out of each of these. I'm just going to let the calculator do that for me. Yes, you can use the calculator for this one. Remember, leave off the pi, otherwise we'll get a decimal. So we've got 4 pi over 5. And of course, we could put rads on all of these as an answer, radians, but without radians, we do know that this is in terms of radians. Okay, so you might want to just do the last 2, but make sure you show the conversion, the times pi over 180 degrees. This would be pi over 4, and this is going to be negative pi over 3. All right, rewrite each angle in degree measure. Do not use a calculator. All right, so we've got a radian. So what I'm going to multiply by is the other fraction, the inverse. So I would put the pi down here and the 180 degrees on top. I could include the radian if I wanted to, but because there's no radian here on top to divide out with that radian, I'm just going to leave it off. Do not use a calculator. Well, I know the pi's divide out. 6 will divide out of 6 once. 6 goes into 180 30 times. Notice I still have the degree symbol. That leaves me to multiply 30 times 15. So I'm going to end up with negative, it was negative right here, negative 450 degrees. Or you could do that on your calculator. Again, I would not include the pi's. I'd multiply 15 times 180 and divide it by 6, and you should get the result of negative 450. Don't forget to attach the degree symbol. Without the degree symbol, negative 450 would be negative 450 radians, which is quite different than negative 450 degrees. All right, so for all of these, let's show the fraction we're multiplying by. Let's go ahead and make that over 1. Get the pi's out of the way, they divide out. I could struggle through this by reducing without a calculator, but that will be fine. I will, if we use a calculator for this work. So I'm going to do 28 times 180 on top and put the 15 and hope it gives me a nice fraction or a nice number. Okay, 336 degrees. All right, I'm going to find this answer first before I get it by mental inspection before I multiply by the conversion. If we think about negative 4 pi, easy peasy, lemon squeezy, negative 2 pi is negative 360, but then another negative 360 or another negative 2 pi, this should be negative 720 degrees. It's 2 complete rotations in a negative direction. And in degrees, that would be negative 720. Again, let's divide out the pi's. Just multiply these 2 numbers, attach the degree symbol. Don't forget it because it is quite different. Negative 720 degrees would be quite different than negative 720. All right, here we're allowed to use the calculator and we're going to round our answer to 3 decimal places, convert from degrees to radians. So here again, back to put the radians on top, 180 degrees on the bottom. So I'm going to do this kind of quickly. It's all calculator work. You can go to your calculator. Don't forget that the degree symbols will divide out. All right, now pi, on this one, I would include the pi in my work because remember, we want a decimal to 3 places. So negative 46.52 times pi all over 180. How many places are we rounding to? 3. So negative 0.812 degrees. No, we're changing to radians. So if I wanted to label rads, that's fine. I do want to make sense of this real quick with you Negative 46 degrees approximately. We're doing this by inspection so we can round a little bit. I am going to go back to one of our previous circles. Negative 46 degrees would be about right here. That's a little more than halfway down into quadrant 4. So negative 46 degrees would be about right here. Well, if we think about the radians, that would be a little less than negative 1 radians would be right here. So negative 46 degrees is about right here. So I would say that negative 1 would be too big in radians. So I have to go a number smaller than negative 1, or at least the absolute value. So that would be about right, 0.8. Alrighty. So let's go ahead and finish these up. 395 degrees is one complete rotation all the way around the circle and a little more. So I'm past 6 radians. Oh, I need to go that way, sorry. I need to have an answer that's going to be a little more than 6 radians. And as it turns out, if we round correctly, we get 6.894. 83.7 degrees is more than 60, and I know 60 degrees is 1 radian, so I bet this answer is a little more than 1. And when we do the computations, we do get this, rounded to 3 places. Okay, our last objective on this page is to convert the angle measure to degrees. So I want degrees, so that means the degree has to go on top of the conversion fraction. And just all the calculator work. And we're going to round our answer to 3 decimal places, and it's going to be degrees. Don't forget the degree symbol. This is a large degree measure. 6.5 pi. Well, 6.5 pi, well, that would be 2 pi. All right, and I'm going the wrong way. This would be 2 pi, 4 pi, 6 pi. So let's see, think about how many times we've gone completely around that circle. At least 3 times. So 3 times 360, and I still have more to go. So that makes sense. Negative 32.659 degrees. That makes sense because negative 0.57 radian would be about right here. Because I don't want to quite go down 1 complete radian. So about right here would be about half of 60, or, yep, negative 32 degrees. And a little bit more. All right, so the takeaway here is when we're converting, we either multiply by pi over 180 degrees or 180 degrees over pi. And we pay attention to how they want us to report the answer, rounded or in terms of pi. And if you get a radian answer, then you don't have to write the rad on the answer. But if you get a degree answer, it's critical that you put the degree symbol on that answer. All right, the other part of our objective in this lesson is we're going to revisit the topic of coterminal angles and supplementary and complementary angles. But this time, instead of looking at those topics with degree measured angles, we're going to look at radian measured angles. All right, determine 2 coterminal angles in radian measure. Previously, we had degree measure, 1 positive, 1 negative for each angle. So let's remind ourselves about coterminal. That's where we added or subtracted multiples of 360 degrees. Well, if we're talking about radians, 360 degrees is equal to 2 pi. So for this objective, to get coterminal angles, we're either going to add or subtract multiples of 2 pi to the given angle. I wouldn't want to add degrees to a radian to accomplish getting a coterminal angle. All right, so we have 2 blanks, one for the positive and one for the negative. All right, I think I'll use this space right here. All right, so again, that subscript just means I'm looking for a coterminal angle. So 7 pi over 6. It's already positive. Let me go ahead and add 2 pi. Instead of adding 360, I'm going to add a whole rotation of 2 pi. I'll make 2 pi a fraction by putting it over 1, since 7 over 6 is a fraction. So I need a common denominator. So the first theta, that's what this is, a theta angle. That represents an angle. I need to multiply 2 pi over 1 times 6 over 6. So that's going to give me 7 pi over 6 plus, might as well just memorize 12 pi over 6. 12 over 6 is 2 pi. So same denominator, add the numerators. So we're going to get 19 pi over 6. Well, I need a negative angle too. So in that case, let me go back to, now this is my second one. Let me go back to 7 pi over 6, and I want to subtract 2 pi. Let's see if that gives us a negative measure. So 7 pi over 6 minus 12 pi over 6, because remember 12 over 6 is equal to 2. 7 minus 12 is negative 5. So negative 5 pi over 6. Okay, done. All right, so let's look at, let's say 3. We'll do 3, and then I'll leave you guys to do 2 and 4, and we'll check with the key. All right, notice that negative 7 pi over 8 is already negative. So let me just start by adding 2 pi, because I think that will get 2 whole is more than negative 7/8 if we ignore the negative. That's going to get me into the positive measures. So let me just kind of explore when I add 2 pi if I'm going to get a positive or a negative measure here. I should get a positive, because 7/8 is definitely less than 2. All right, I need a common denominator. So that means I need an 8 here. So that's 16 pi over 8. Because remember, 16 over 8 is equal to 2, so that makes sense. So negative 7 plus 16, do it on your calculator, that should be 9. 9 pi over 8, keeping the same denominator and just collecting the numerators. All right, well that's positive, so that tells me that if I want a negative measure, that I better go back to negative 7 pi over 8, the original problem, and subtract 2 pi. So minus 16 pi over 8 to get that common denominator. So collecting, I'm going to get what? Negative 23 pi over 8. Yep, got a positive and a negative and a positive and a negative. Sometimes depending upon what this angle is that's given, in order to get some positive measures or even negative, you're going to have to add 2 pi, maybe more than once, to get into the positive numbers. Okay. All right, I'm just going to go ahead and fill in the answers here. I would encourage you to go through the work and determining that you did also get these values by adding and subtracting multiples of 2 pi. It doesn't matter if you put the positive one first or the negative coterminal angle first. It doesn't matter. And of course, there's an infinite number of answers that you could have. I mean, correct answers that you could have. It just depends. I mean, you could add you'd have to add like a multiple of 2 pi. You'd have to add 4 pi here or 6 pi here. But I think it's just as easy to add just the 2 pi and land on the first coterminal angle that you get. All right. The last topic is to revisit complementary and supplementary. Remember that complementary means 2 positive angles. That's the angle symbol, angles, that add to, well, it'd be 90, but in this case, 90 is now pi over 2. Supplementary means 2 positive angles that equal or add to 180 degrees, but we're talking radians, so 180 degrees is pi. And remember, if any of our answers come back negative, then we don't have a complement or a supplement, all right? So like we did last time, let's work with the complement first. All right, complement means 90 or pi over 2. So take pi over 2, subtract the given angle. Let's see what our answer is. If it's positive, it goes on the blank. If it's negative, we cross it off and put none. Common denominator. So we're going to multiply. We need a common denominator of 4, so we'll multiply by 2 over 2. So 2 pi over 4, that makes sense. Pi over 2 minus 3 pi over 4. That's going to give me a negative 1 pi over 4, which means that I do not have, I'm going to put a C for complement here, and put none. That makes sense because I'm going to actually revisit a previous circle. Let's find 3 pi over 4. Let's find 3 pi over 4. So 3 pi over 4 is already well past 90, so it cannot have a complement because it takes 2 angles to add together and give you 90 degrees, or pi over 2. So I'm well past pi over 2. So I should have no complement. Now I will have a supplement, and just by eyeballing it and inspecting it here, I can see that this other pi over 4 section would get me down to pi. So pi over 4 should be my answer that I'm going to get to the supplement question. But numerically, let's just support it. So supplement, 180 degrees, but that's pi, minus the given angle, 3 pi over 4. So put pi over 1. We need to multiply by 4 over 4. So 4 pi over 4 minus 3 pi over 4. And indeed, that is positive, and it's pi over 4, just as we thought. So the supplement would be pi over 4. All right, so for number 2, let's just predict if I'm going to have answers for complement and supplement. And the way I would suggest doing that, we have to kind of have our mental math going here. Look at just this fraction 12/5. 12 over 5 is more than 10 over 5. And 10 over 5 is 2. So what we can really say is that this is greater than 2 pi. Well, greater than 2 pi is greater than pi over 2, and it's greater than pi, so we should have a none answer. Both these answers should be none. Okay, how does our work support it? Well, we go to complement, we take pi over 2, and we subtract the given angle. We can clearly see we're going to get a negative answer. Common denominator is 10, so multiply by 5 over 5 here, and 2 over 2 here. So 5 pi over 10, yeah, that's pi over 2. Minus 24 pi over 10 when I multiply, that's going to be negative. So you might as well just stop here, just say none. Likewise, supplement is pi, 180 degrees minus 12 pi over 5. The common denominator would be 5, so multiply by the fraction, the clever form of 1, 5 over 5. We're going to get 5 pi over 5, which is pi, minus 12 pi over 5, but again, clearly that's negative, so none. All right, for number 3, we can certainly do the same kind of math here, but I see that pi over 6 is familiar to me. Okay, pi over 6 is actually right here. And it falls, pi over 6 falls well less than pi over 2. It's 90 degrees, which it's going to have a complement. And it's actually these other 2 pi over 6 sections. So 2 pi over 6 would be equivalent to pi over 3. So I'm predicting that pi over 3 is going to be my complement. And then it's going to take 5 more pi over 6 sections to be a supplement, so to get over here to pi. So I'm predicting that my supplement answer would be 5 pi over 6. So I think pi over 3 is complement answer, and 5 pi over 6 is going to be the supplement. But our math should support that. Complement, pi over 2 minus pi over 6. Multiply this first fraction by 3 over 3. So that gives me 2 pi over 6. And we'd probably want to reduce that to pi over 3. Exactly what I predicted. Supplement pi minus pi over 6. Multiply by 6 over 6. So 6 pi over 6, because that's 1, minus 1 pi over 6. So that's 5 pi over 6, exactly what I predicted. All right, so in this lesson, we converted from radians to degrees and vice versa. We revisited the topic of coterminal, supplementary, complementary, but not working with degree measured angles, but working with radian measured angles.